Hello and welcome back to the e-commerce project. This is part 4. This starts a 3-part mini-series, first looking at the basics of Elasticsearch. In the next tutorial, we'll go ahead and start to create an API for our inventory system, and then swing back in the third tutorial where we'll go ahead and integrate Elasticsearch with DRF. If you have randomly found this tutorial and you're wondering where the other tutorials are, part 1, 2, and 3. If you head over to the main homepage for the channel and then head over to the Django Project Mastery, you'll find a playlist here and you can view the previous tutorials from this tutorial, although you can just follow along because the code will start from here. So you don't have to have gone through all these tutorials to watch this tutorial, because this really also kind of buddies up this tutorial. If you're just interested in learning the basics of Elasticsearch, or at least to kind of get you started, then this also could be a good tutorial for you. If you have missed any of the tutorials so far we've gone ahead and developed a database design for the inventory app, the main application which manages products in your store. And then we've gone ahead and implemented that database with Django. In the last tutorial, we looked at how we could actually utilize that in a very simplistic way, querying the database and creating a very simple filter system for and based upon our database design. So what to expect from this tutorial? There are 2 parts of this tutorial. The first is just an optional step. I'm going to go through a simple set of slides explaining a little bit about Elasticsearch, building up towards part 2, where we go ahead and implement Elasticsearch into our existing Django project. So we'll take a look at installing, running some queries where we might want to utilize Elasticsearch within the inventory app. So by all means, skip to the second part of this tutorial, have a look at the timeline in the tutorial's description, the video description, and head across to where we start actually implementing it in Django. Otherwise, we're just going to talk a little bit about, in this case, what an index is, to give us a rough idea of what's going on here and why we might need Elasticsearch. So the first thing that we ought to have a general grasp or understanding of in general database terms is, what is an index? A database can store an ever-increasing amount of data. And of course, as that data scales, potentially it means that when we try to search and find that data or specific pieces of data, it can take longer because there's more items to look through. Indexes provide logical, structured ways to access data quickly. So on a typical relational database, we could set up an index. And what typically happens when we set up an index is we make a copy of the data that we want to index, and then we go ahead and use different technologies or methods to create an index so that that data becomes easier to find. So we will find that indexing is a technology found on all major database systems. And for most applications, that's more than enough to ensure the performance of the application or the service. So that leads us over to Elasticsearch. So I think of Elasticsearch as a very specialized tool, which is much more focused on search functionalities. So we could think of this software as a search and analytics engine for all types of data, which allow us to store, search, and analyze big volumes of data. So one of the main benefits of this tool is that it provides a really good API. So we can send requests to the API, it then does its thing and then returns back the data. So we can really kind of micromanage this type of tool. And because of that also, it allows us to easily integrate this tool. Maybe not at the start of a project, but this might be a tool where we slowly integrate our project over a number of iterations. So we can start very small here and start to offload some of the work over to Elasticsearch microservice, if you like. So although it is fairly complicated to explain exactly what it does under the hood, the mechanics of this are quite easy to set up and to grasp initially to get your project starting to integrate with an Elasticsearch service. So the reality of what's happening behind the scenes really requires a degree of information or a degree in information retrieval to understand how it works. It is a very kind of complex system. So internally, we're using an inverted index, which we can then go ahead and just consume via our RESTful API. So like we do with queries, we would send essentially a query over to Elasticsearch service. It would then run that over its indexes to search and find that information in near real time to then return that information back. It's pretty much like making a query. That's what we're going to build this up towards. So we'll go ahead shortly and have a look how we start to implement that within our project. So it just happens that Elasticsearch is written in Java, and thus it does use the JVM. So because we're writing here in Python, we will find that we're going to be spinning up another Docker container and containing Elasticsearch in that container, or running from that container. Now, don't let that put you off. This is a fantastic tool to start learning and utilizing if you're looking for scaling data that requires search, or as we start to see, it's not just about searching and utilizing it as a search engine. That's just one of many things that we can utilize Elasticsearch for, but that's where we are leading to. So Elasticsearch, a specialized tool to create, for example, indexes to make our data organized in a way that's going to allow us to search for that data in near real time. So there's a little bit of terminology to understand, and that starts to help us understand what's happening and how this is going to be potentially be utilized in our project. So first of all, a document. So this is the main and basic unit of information that can be indexed. So we could say, for example, you'll see in Django shortly, we're going to create a document and we're going to describe the data that needs to be indexed. So that's our document. So let's think of our document maybe as tables in a normal database that describes the data, the rows or the fields, sorry, that need to be indexed. So next up we have this terminology index. So we could liken that to database. So typically what you might read is that when we say the word index, we're not necessarily referring to what I've described earlier in its traditional sense. We could think of an index, in this case in Elasticsearch, as the actual database. So whereas the document might be the tables or equivalent in a relational database, let's think of an index as the database. So in that case, we can say that the index is a collection of documents that have similar characteristics. So for example, a normal database would have tables that are kind of all related. So it's important to understand that our index needs to be unique, because when we actually send queries to the service, we're going to need to uniquely identify the index that we want to work with. Remember, the index is the database. In equivalent terms in relational databases. So we're going to need to know what index we're working with to select the correct data. So we can say loosely that indexes, in terms of Elasticsearch, they're found on shards. So a shard is a very important aspect, and this is where we start to see how this system can be very specialized and scaled in a way that's going to improve performance. So a shard, this is the ability to subdivide an index into multiple pieces. So just in general terms again, why might you want to take an index, which is already really quick, an organized way of organizing data, why would we want to kind of break that up into multiple pieces? Well, potentially that makes it quicker to find. We're horizontally scaling this, and it potentially makes it easy to find, and potentially for scalability to allow multiple people to access data by subdividing it. Potentially it does then mean that again, just for performance, it makes it quicker to find the information. So each shard in itself is a fully functional and independent index as well, which is fairly kind of difficult to understand at this point. This is information, but like I was suggesting, this is providing horizontal scaling, and this is all kind of feeds into this performance idea. And like I said earlier, this idea that this tool is a specialized tool for indexing data, for example. And these are some of the tools that really kind of set it apart from maybe other relational type of databases. But as it stands, all we really need to know in some ways is that an index resides on a shard, and we will need this terminology when we start setting up. So having a general idea at this point kind of helps, but hopefully you're starting to see what's going on. We have a document that resides in an index is in a shard, and these are all kind of manageable components that we have. So the shard resides in a node. So we can think of a node as a single server instance or Elasticsearch that is part of a cluster. And we'll talk about clusters in a second. So we have a node. So shards reside in nodes. So again, it's kind of another manageable component, if you like, we have in our system that we can start to optimize. You can see here that this will run on a single or multiple server or VM or container. So we can take and start to replicate many of these nodes. And again, this is just about scalability, performance, large accessibility to our data, large quantity of accessibility requirements to our data. So the last component here, the cluster. So we could say that a cluster consists of one or more nodes. So the node resides on the cluster. So that takes us through some of the basic terminology, and we'll start to utilize that terminology as we start to implement this into our project. So let's go ahead and now get this started by, if you haven't already, download the repository. If you're going directly to GitHub via Google, you're looking for the Django E-commerce project version 2. There should be a link in the description of this video, and you can see that we've already completed part 2 and part 3. So go ahead and download that. Of course, if you want to, you can access that in different ways, of course, but I'm just going to download it from here. So I've gone ahead and downloaded that and opened up part 3. So that was the previous tutorial code, and then I've just renamed the folder part 4, and now we have all the code. So the first thing I need to do, because I'm going to need the database potentially, is just make sure that I remove the migration. I'll just move that into the trash there, so we don't need that, and I think we're good to start. So before we start, if you haven't completed any of these tutorials so far, you will need Python installed. I'm just making that assumption, and in addition to that, we are utilizing Docker, so go ahead and download Docker Desktop, and everything should be automatic. Just install it, maybe restart the computer, and then everything should start through this command here. Right, so hopefully you've got all that in place, and let's get started. So just a little bit of admin before we begin. What I'm going to do is just move the fixtures from the inventory app over to the demo. So there should be no other changes that are needed. I just want to make sure that these fixtures are purely associated with this demo app, which is our kind of application we're developed in the previous tutorial, which is just kind of a throwaway app just for us to learn some of the different aspects of Django, and in the last tutorial, querying the database. So next up, let's go ahead and create a virtual environment. So if you're running Windows, you're probably going to need to type in py-env-venv. If you're on Windows, if you're running Mac, we're going to run virtual env venv. That's going to create a new folder called venv in our project here, and then we go ahead and activate. So if on Windows, you're going to type in vtab and then / scripts with a capital / and then activate. That's on Windows, and then on your Mac here, source v tab b tab a tab. So that activates our virtual environment. Then we go ahead and just install all the requirements. So pip install requirements. Okay, name action distribution requirements.txt. Okay. Let's try that again. Apologies, we've forgotten the R flag. So don't forget the R flag. So that goes ahead and installs everything inside of our requirements. So that sets up our project nicely. Now, we are going to be utilizing a new package. We'll install that shortly, but let's go ahead now to Docker Compose, and let's go ahead now and just create our new service. So I've already gone ahead and done this. So I'll just explain what's happening here. I've created a new service here called eSearch, Elasticsearch. Container name is just going to be search, and then we're going to use the image Elasticsearch 7.14.2. If you're not too sure what version, just head over to Docker Hub. So let's just type in Docker Hub here, and then search for the official image, and you can see, have a look to see what are the current versions of Elasticsearch or the images. So this is where the image is going to be downloaded if you're new to Docker. Right, so 7.14.2, that's what we're going to be utilizing. And next up is discovery.type equals single node. Right, so going back to the presentation, you remember we had a node, this idea of a node. So we had a document, an index. Index was on a shard is on a node. So our node is identified by UUID on startup. It's important that we have a primary node so we can then access that data. Now, generally what's happening here is that on the system, when the service starts, we have this idea of node discovery. So nodes can reside on multiple servers, VM, and containers. So there's essentially what happens when your Elasticsearch loads up is that it's going to do a lot of searching for different nodes. And that's a process which we don't typically need to do in this kind of development environment while we're developing. So that's something much later on when we start actually deploying this, thinking about the nodes, shards, and so on. So what we're doing essentially here, if I just drop this down, essentially what we're doing here is we're just saying that we're going to create a single node, which is going to be our node here, which is going to run and maintain all of our indexes and documents. So we know exactly where we're working from, just from a single node. There isn't any other duplicate nodes here, or isn't any kind of expandability or scalability that we're trying to perform a single node. So if you're not too sure, or if you want to read a little bit more about that, just head over to the documentation. So over here in elastic.co, have a look for discovery and cluster information settings, and that will take you through the different settings. So talk a little bit more about single node discovery. There's not too much to read about it really, just a simple passage there, which will help you identify. But you can see here, this node will elect itself as the master, and it won't join a cluster with any other node. So we're just creating a single node setup for development. So finally here you can see that we're running port 9200. So we're going to be accessing the API, the Elasticsearch API through the 9200 port. So we can start to work straight away with Elasticsearch through its API once we get it started. But how we're going to interact from Django to Elasticsearch, we're going to utilize this package here. So this is going to allow us, or give us a wrapper, if you like, which is going to convert our queries that we're going to run into requests and send that off to the API server, the Elasticsearch server that's running, and then that's going to return the data. So this is just a nice kind of wrapper that's going to allow us to interact, so create indexes and then query our data in Elasticsearch. So let's go ahead and install that. So you just need to pip install that. So I already have this installed. So once you've done that, just head over to your project settings, and you just need to make sure that in your installed apps here, we have Django _Elasticsearch _DSL. So that kind of integrates that with that new package, so we can start utilizing that straight away. Right, so now we have the Docker Compose file completed. Obviously, we want to make sure that we can actually run it. So you can see this is what we're going to end up with. So I'm just going to delete that. So what's going to happen is the image that we've selected 7.14.2 is going to be downloaded. That's then going to be run together with Postgres in individual containers. So let's just see that in action. So we just need to type in docker compose and then up, and then we use the D flag. So you can see that it's pretty much instant here. And you can see now I have a container set up here with our Elasticsearch and Postgres database. So now we can go ahead and use curl, for example, from the command line here. Now, if you're using Windows, you won't be able to use curl or curl from the command line. You'll need to, if you have Git installed, you could use a Git bash shell, or potentially there are different ways for you to integrate curl into the command prompt. Go ahead and just do a quick search. Probably you'll probably find a good page. I think I actually had a quick look. If you type in curl on Windows, it's probably going to send you to Stack Overflow. So a page like this is going to just give you a little bit of information how you can install curl into your terminal if that's what you want to do. But essentially curl, if you're not familiar, it's going to allow you to send and receive data from an API, for example, like we're doing now. So let's go ahead and just test to make sure that everything is working. So let's type in, we're going to get, so we're going to say localhost, and remember this is port 9200. That was our new service port, or the default port. So we're going to say cluster and then health. So we're going to, there's only one cluster. So we're going to check this out, and you can see here that we've got cluster name, Docker cluster, status green. And there we go. So that's a little bit of information just to test to make sure that the cluster is working, that your Elasticsearch is working. So the server looks like it's okay. So let's just get rid of that. So next up then, if you aren't familiar, in the demo app now, in the inventory app, we do have models. You can use the link in the description of the video to go have a look at the bigger, at the database ERD, sorry. But this is our model that we're utilizing. So what we're going to do now is just migrate that to our Postgres database running in Docker. So we can do that by utilizing a management command that I set up here to load all the fixtures, the data fixtures into the table after we make migrations and migrate. So just make sure there aren't any migrations in this folder. Don't get rid of the underscore or the dunder init file there, or module. And let's go ahead now and just run this. So here I'm going to have to type in Python 3 on Windows, just py. And then I'm going to run the command. So manage.py and then load fixtures. So there's quite a lot of fixtures here. It says settings, object has no attribute, Elasticsearch. Okay, so there's one other thing that I need to do. Apologies. If you go into settings, we actually need to tell Django where to actually find the Elasticsearch server. So somewhere at the bottom, let's go ahead and just do exactly that. So it's already prompted us here. It's looking for this attribute. So we can pretty much just copy that. And then let's add this in. So basically we just need to, let's give us a name, default. And then we just need to describe where the host is. So hosts, and then that's going to be on the local host, and then port 9200. So we're pretty much all we've done there is just we've told Django where to actually find the service. So let's go ahead again and run that command. So load fixtures. So you can see now what's happening is that we've migrated all the models from the inventory, and we're now just going ahead and installing all the objects. And there's quite a lot there. It might take a minute on your machine. So I'll see you in a second. So now we've got the basics set up. Let's go ahead and work with our data. So first of all, we're going to need to build a file called documents. So remember, documents are in Elasticsearch, are JSON objects, or the data is going to be converted to JSON objects. And this is what's stored within the Elasticsearch index. And again, what we're going to develop here is we're going to essentially in our document describe what data we want to store. And this is considered then the base unit of storage that is going to be stored in Elasticsearch. So in our inventory here, let's create a new file. We're going to call this documents.py. So here we're just going to now define what data it is we want to actually kind of store in our index. So at this point, we're going to need to bring in a few different resources. So from Django _Elasticsearch DSL. So that was the module that we installed. Let's go ahead and just import document. So we're going to create a new document. Okay, and I think I've got it right. And then from Django _Elasticsearch DSL, and we're going to import our registries. We're going to need to be able to register this. So we're going to register our document so it then becomes available and usable. We're going to import registry. Okay, so we're going to need some models. So from .models, let's import the product. Let's use the product inventory table as an example. So that just brings in our model. One of them is the product inventory table. So the product inventory table, if you're not familiar, that's going to store all of the products that you currently have in stock in your e-commerce store. Right, so now we can use the declarator registry. Register _document. So let's go ahead now and create a new class. So this is going to be, I'm just going to call this the product inventory document. And then we're going to bring in document. Okay, so now we just need to basically just describe what it is we want to actually index. So let's move that down. Right, so first of all then, let's create a new class called index. And then we're just going to say the name equals. So this is the name of the Elasticsearch index. So we're going to call this product inventory. Yep. And then next up, we're going to then create or define the model and the fields we want to actually index in Elasticsearch. So let's say Django. And then model equals product inventory. And then just define the fields. So let's go ahead and do fields equals. And then I just know there's some fields in there called, there's a field in there called ID, SKU. So that's the individual unique number. And yeah, let's just stick with that to begin with. Right, so now we defined what we want to actually index. That's going to be the product inventory table, data, ID, and SKU. Right, so now we've done that, let's go ahead and see that in action. So the first thing that we need to do now we're ready, is to actually make our index. So we need to tell Elasticsearch that we're ready to make our index. We've defined everything we need to here. So let's go ahead and do that. So Python or Python 3 or Py, and then we're going to need to use manage.py, and then we're going to say search _index, and then rebuild. Okay, so it looks to sequence item 0, expected string instance. Looks to be a little bit of a problem here. So just looking through the code very quickly. We need a capital there for our index. Let's just see if that works. And there we go. So it was just a typo there. We needed a capital for our class. So now we're asked, are you sure you want to delete the existing index? Yep. And there we go. So it's now going to be creating an index for product inventory. And you can see that it's indexing 34,000 objects. So that's the amount of rows that we have in our database. So the most obvious question now is, well, how do I actually access that data now? So we can do that in many different ways. We can utilize that through Django, or we can directly just send a request. Again, because we have the Elasticsearch API, we can just work directly as well. So let's go ahead and see if we can, first of all, run a search utilizing the API. Okay, so what you're looking at here is an example. So we're going to use curl again, and this time we're going to send it to our server, and this time we're going to run _search, and then pretty referring to the fact that we're going to return JSON and format it in a way that's readable, and then we just define the content type, so application JSON. So if you are running, for example, Postman or any other kind of API tool to make requests, you can just set it up with that data, and then you can see here what we're running is a query. So a bool, so we're going to return, it's going to be true or false, return an item, so it must match SKU. So basically what we're doing here is we're trying to check the data that's been indexed, we're trying to make a match, and where the SKU equals this number here. So somewhere in those 32 or 34,000 entries that we've now added to our index will be one item that matches that. So I'll just go ahead and copy that in to here. I just remove it from there, and we just go ahead and run that. So I just move that up a little bit so you can see what's happening. And there we go. So we've now returned hits total value 1, max score, index. So we're told the index, and then the type _doc, ID is 1, and then score again, source, and then we got the ID of the actual item, and then the SKU of the item. So remember, in our code, we've identified these fields, ID and SKU. So if we would expand these, you would see more information here. So we can obviously now utilize that as a kind of general request to an API server. We can now utilize this JSON data to extract and then to place on our page. So we can work directly from our API front end to collect information from the Elasticsearch service. So one of the main features of this Django Elasticsearch DSL tool is it just allows us to simplify things. We can run it directly from Django, or run requests, sorry, directly from Django. So I could put it here. For example, we've got the demo running, so I could go into the view and set it up in the view, but I don't want to go into that much depth at this point. Again, we are going to come back to this after the next tutorial where we build a simple API for our inventory. We'll then come back and use the API version of the Elasticsearch to then integrate it into our system more comprehensively. So I just wanted to show you the general boundaries and to kind of get you over the line, starting to utilize and think about Elasticsearch. So let's go in and just go into the shell. So we'll just open up a shell here. So let's go ahead and just grab this. So we're going to say from, as going to be e-commerce dot inventory dot documents. Let's import product inventory document. Okay. So let's run a little filter. So for example, let's say X equals, and then we're going to bring in product inventory document. And then let's now, for example, search. Okay, so we extend and we run search, and now we just define what we want to search. So we're going to say dot filter. So we're going to run a filter and on a term. And then, for example, SKU equals. So we're going to try and match any SKU that equals this here. Let's just grab that from the previous code. If you're not too sure, just head over to the demo and then go into the fixtures and have a look at the product inventory table. You'll find an example SKU here. So let's just grab that product. Okay, so let's go ahead and run that. So essentially that has now run a query. So we've now queried, sent a message off to the Elasticsearch API, and then we've now returned some data. So we can just now say for Z in X, we can just kind of loop this out. So for Z in X, let's go ahead and print x.sku. So let's just print out the SKU of that data. And you can see that we don't have anything. Search object has no attribute SKU. Okay, because I've typed it out wrong. I should have said z.sku. So let's just do that again. So for Z and X, let's go ahead and print out z.sku. And there we go. So we now return this data from the Elasticsearch service. So at this point, you can probably see that this can now just be scaled up. We can collect more data. You can see there's a lot of data here that we can collect from our data, and then we can go ahead and return that. And of course, if this doesn't make sense to you, essentially what we're doing here, why we're doing it here, we can do this in the template. This is the same principles again. So in our view, we would run something like this. So we'd bring in product inventory document, import that into the view, and then utilize that to build a query. And then we can obviously then return X into our template, and then we can put that data onto our page, for example. So we can work that way internally if we're just using the Django templates. And of course, if we're using Django API, we'll see that later in a tutorial, in the coming tutorial. Right, so that's a simplistic way of kind of grabbing data then from the Elasticsearch service. So I hope that gives you enough to kind of start thinking about a single table. But probably what the next thing we're going to ask ourselves is, well, how do I use foreign keys forward and backwards? So let's go ahead first of all. Let's just grab some information maybe from the product. So we're going to need the product name, for example. So let's use the foreign key. So we've got a foreign key here called product, and then we're going to grab the data here and index the name as well as the product inventory data. So that is really simple. All we need to do here is just define the foreign key product, and then that equals fields. So we just need to basically just describe it. So fields.object object field, and then let's go in, and we're just now going to describe. Looks like we're going to need to bring in fields. So document fields. Okay, so let's go ahead now and describe this. So we're going to say properties equals, and then so basically in the product table there is a field called name, and we want to grab that data. So we're going to grab that data, that field, and that's going to be, we're just going to describe what type of data that is. So that's a text field, and there we go. So going back to the database here, we've selected the foreign key, and now we've gone back into this table, and we're now grabbing the name of the product. So having done that, we should now be able to access it. So let's just open up a new shell here so we can follow this along. It's Python. I'll go into the shell and run this. Oh, what's happened there? Okay. So we just run the virtual machine. Run that again. Okay, so we're in the shell. So let's go ahead and access this again, but this time we're going to select the name. So before we do that, let's just make sure that we update. Remember, we need to actually kind of update. I thought I had it handy here. Okay, so we're going to need to activate or remake our index because we have some new information that we want to include in the new index. So let's go ahead and run Python 3 manage.py. So same command again. We're going to use search underscore index rebuild. So you can see that it's going to remove the other index and then create a new index here. Right, so now we've created a new index, we should now have this other data available, and that's going to be accessible through product.name. So let's go back into here. Let's so from e-commerce .inventory .documents. Let's import. Well, we got import product inventory document as, let's just call this PID. Okay, so we can reference it to it as PID. Right, so now we have that in place. Let's go ahead now and create a new query. So x equals PID dot search. Okay, so hopefully that makes sense. Search. And then this time we're going to, let's just run the filter again. Use term. And this time we're going to say, for example, product. Oh, we're just going to say name. Sorry, name. Name equals. And then see if we can grab a name. So let's go back into the fixtures here. We're looking for product. The product fixture. So this one here. So these are the products. So let's go for the name. We'll just grab the first one. And then we put that in the middle there. Okay, so we're going to run that query, see if we can find this data in our Elasticsearch service. So go ahead and do that. And then we're going to need to end that, of course. Okay, so has no attribute search. Okay, I spelled that wrong. And let's just make sure we put the bracket at the end. Okay, so for Z in X, let's go ahead and just print this out. Print Z dot name. Okay, so this time we can see that we received a warning. And it doesn't look like we have any data that's being returned. Okay, so we've not received any data. We've not returned any data. So this gives us an opportunity now. Let's go back into our shell here. Right, so let's use curl again to actually try and grab some data, because essentially we've indexed all this data. So the first item in our database should have a name. All the items should be indexed with a name from the product inventory table. So let's say curl. Let's go ahead and kind of get data again. So we need to find localhost and then the port. And then we're going to, this time, use doc. And then we're going to essentially just define which document we want to return, which is going to be number 1. And then we just use pretty again to make it look good. And there we go. So we'll run this. And you can see here that we have potentially an error, incorrect HTTP method for URI / _doc1 and get allowed post. Okay. Okay, so that doesn't work. That's because I haven't provided the name product inventory. Product inventory. So obviously I need to identify what I actually want to find, where the document is going to be. Okay, let's give that a go. And there we go. So now we've returned the information, and you can see now that the name has been indexed with the data. So we have here source product name, Wildstar running sneakers. We have the ID and the SKU. So we can see that data is being indexed correctly, or how we expect it to be. So let's just go back and see if we can then return that again in our shell. So I'm just going to exit this. And let's just go back. Okay, so from e-commerce inventory document import product inventory document. Let's just go for that. And then let's say x equals product inventory document dot search. So we've got product inventory document, and in actual fact we can just run search, and then the same type of thing here, like query, and then let's go for a match. And then this time again, so we want product name. So I was using the dot earlier, apologies. It's a product _, and then name, and then equals whatever name we have in our database. So taking a look in our fixtures, we have this here. So this should return multiple items. Remember that there should be multiple items attached to this name, simply because in our product inventory table there are multiple versions of this shoe, different colors, etc. So let's just add that in, pinch that off. So now we should return some data. So let's go for the quick loop again. Let's just print out Z. That should then return multiple items, and there we go. So that's how to grab the data then from the foreign key. So this is going to work also if you've got a reverse key. So for example, here we've got a reverse foreign key. So our foreign key here is connected to our product inventory table. So let's go ahead and also now collect how many units we have of that particular product, for example. So let's just drop that down. Let's go into, let's get rid of that. Let's go back into here. Let's go ahead, and this time what we need to make sure of is that in our models, if I just scroll down, I think it's the bottom here, we've got the stock table. You can see that this foreign key here has a name, product inventory. So we need to make sure that we're referencing that when we're creating this link here. So let's go for that. So this should be called product inventory equals, and then in actual fact, what we can do is just copy the rest here. Let's do that. There you go. Okay, so inside of the product inventory, we want to go for units. So let's do that, exactly that. So this is going to be units. Now the units here is an integer field. So we want to kind of change this into an integer field. Oh. I don't even know that, do I? Integer field. And then that should now be set up for that field. So let's go ahead now and see if we can rebuild. Okay. And now hopefully we should be able to extract that information, or that should be available now within our index. So let's go and have a look at the data. Just use the command we used earlier. So we're just going to get the first item in the index, and you can see now we have product inventory units, as well as the name, the ID, and the SKU. So that's pretty much how far we need to get at this point. Hopefully that was enough for you to start exploring. Have a look at the documentation and see if you can explore the data set a little bit further. Now, next up, we're going to go ahead in the next tutorial and implement an API for our inventory database. So we'll go ahead and build and test that. And like I said, we'll then come back and then integrate Elasticsearch into our API. So that's the plan. Hopefully this was useful and interesting, and I hope to see you in the next tutorial.